Welcome, everyone. Thank you so much for being here today. Especially thank you because this is kind of the last session of the last day. It's a 3 days conference, pretty long, a lot of work. And we're very excited to see you still stay here today. And that's the right choice. Because actually, when we first got the schedule, they say we're the very last one. We're actually asked, can we get moved to the day before, etc., so more people may attend. But they say, no, you can't. We can't because your talk is too important. And the order of the talks are ordered by the increasing of the importance. So we're the last one. But you'll be happy to find out that's important that you made it, right? Well, make sure you learn a lot of important things. You find it very helpful so that you can end your conference on the strongest note. My name is Sophia Yang, product manager from the Compute Engine team. Join me today are 3 gentlemen here. We have Akash, our developer from the cloud security team. And we have Siri, also product manager from Compute Engine team. And we have Nick from 2 Sigma, our customer, joining us to tell us the story about how 2 Sigma is utilizing our tools to build their most secure environment. So privacy and security has always been the top priority at Google. We want to help you build the most secure environment. And that's why every year we continuously invest in building new features, new tools to help you achieve that goal. And worth mentioning, not only we're building this environment for you guys, we're also using this ourselves. Many products, applications from Google are also running on Google Cloud. And today, we're making our secret sauce, our best practice, our perspectives into 6 simple steps to walk you through, step by step, how to build the most secure environment. And when talking about getting started, before we share any best practice yet, let's just first look at how people mostly get started with cloud. We find out no matter you're one of the Fortune 500 company with thousands of employees or you're just individual developer, often when you get started with Google Cloud, you want to first start by trying all the new cool features, testing out the performance. And at that phase, performance access management is kind of the last thing you want to worry about. And we understand that. That is why we make the getting started state super simple and easy for you. You come to Google Cloud, you create a project. You automatically is the owner of the project. You have full access within the project. Don't have to worry too much about who can access a resource, because your project is created as an isolated environment, so no one else can access your resources within the project. All this is trying to minimize your time to finish your proof of concept, to finish your prototype. So make sure you can totally fall in love with Google Cloud. And then when you're done with your prototype, what do you do next? You're ready to move your production workload, right, your dev and test environment onto us. And that is when we should start talking about how to build the most secure environment. And that takes us to step 1, create an organization. So why creating an organization is so important? Because afterwards, it's much easier to apply organizational-wide policy if you have organization. And talking about building an organization, the first thing you need to do is to set up your organizational identity. And so let's invite Kash here to tell more about how to do that.
Thanks, Sophia. The first things that you need to do to get any kind of security for your cloud is to essentially root your trust in the identities in your system. Without securing your identities and the identities that can access your resources, there really is no hope in securing the rest of your cloud. And that means that you need an identity story, you need an identity provider, and you need policies that you can apply to those identities. Here at Google, we have solutions to get you started here for no matter what kind of company you are. If you're the first way that and 2 general paths in which you can establish your identity story at Google. The first is to use Google as your identity provider itself, and I'm sure that many of you do this already. Google does this internally. We use our products internally all the time. The basic, there's a fully fledged identity system with groups and users and APIs to manage them, security controls and so forth and so on. And it's also conveniently very easy to set up for small customers of Google Cloud. If you're an established shop and you have an existing identity system, such as Active Directory or an LDAP system, you can use Google Cloud or Google Cloud Directory Sync to synchronize those identities and groups to Google and use them and apply them in policies in the Google Cloud product. The next thing after establishing your identity store at Google Cloud, you need to secure them somehow. And fortunately at Google, we've basically been working on securing clouds for many, many years now. First with our internal cloud product, but also now with our external cloud products. We've been dealing with attacks on our internal resources and our customers' resources from state actors, non-state actors, you name it, we've probably seen it. And we have a lot of researchers and security engineers just tracking all of the incidents that we can find, things maybe the rest of the world hasn't even discovered yet. And we then also work on trying to mitigate those attacks with new tooling and features that sometimes we apply internally, but then sometimes we give to you to apply to your own resources. And I'm going to give you a list of basically like a few of the things that I think that you should be turning on basically out of the box for ensuring that your cloud is secure. The first thing I want to talk about is two-factor authentication and security keys. We've been using these internally for a couple of years now, and they have been super effective at eliminating all sorts of account attacks and phishing attacks. The basic idea is that your users get your developers get a security key, and this is a hard-to-phish security device that has to be present every time that your users log in, your developers log in. And so what that means is that if someone can steal my password or trick me into answering questions, an attacker can't actually log in unless they're in possession of the secure device as well. To configure your systems to use this, you can go to the Google Cloud admin console, and you can go to the security settings and turn on the security keys. This is so important. We've actually just announced our own security key products, which should be coming to market at some point in the future. The second thing, after you've secured your accounts themselves, is to secure your connected applications to your identities. I'm sure all of you have seen in the news with various incidents. Basically, if a third-party application can connect to your users and get their data from the cloud and from a cloud provider, it's unclear what that third-party provider might do with the data. And this means that this is like one situation when you have your social media data being collected by an attacker, by a third-party company. It's another thing entirely when it's your corporate resources that are being stolen. And basically, in these situations, your developers, you just need to trick one developer in your company to install an application, or on their phone, or on their browser, and all of a sudden, access to your corporate resources could be granted. So we highly recommend that you go to the Google admin console and turn off all connected applications for all scopes and all APIs that are important to you. In particular, for the Google Cloud Platform, maybe others. And then at some point, if you need to actually have developers delegate access to applications, either first-party applications or applications from vendors you trust, you can vet those applications, and you can use the trusted app configuration tools to whitelist individual apps to have access to individual services. Now, I think I know what most of you people are now thinking. You're probably thinking, this is great, Cash. But the thing that really keeps me awake at night are the attackers working from their undersea layers trying to get access to my cloud. I want to tell you that I, too, worry about these kinds of situations. And we just announced the other day our new set of security features around protecting access to your cloud resources to what we call secure contexts or access contexts. And the basic idea is that I can configure in my cloud console the set of networks or VPNs that should have access to my cloud resources and essentially mitigate and prevent accesses to my resources from outside of those networks. And the good thing about this is not only does it help mitigate against attacks from deep sea, undersea layers, it also helps protect from attackers in volcano fortresses or even moon bases. The final thing I want to tell you about organizations at Google and Google Cloud is that they give you an incredibly powerful tool to organize and manage your resources in a way that makes sense to your business. In particular, we find that organizations are often broken up into individual product areas, and sometimes with different types of deployments. Like, for instance, internally at Google, we often speak about developer or like dev level environments, staging level environments, and production level environments. And you can actually model these things in folders and different projects and apply policies that apply down hierarchically through the policy hierarchy, essentially, so that you can apply a policy high in the policy tree to apply to all resources underneath. Or, for instance, if something makes sense only for a specific product area, you can apply a policy to only the resources within that product area. And with that, I'd like to turn over to Sophia to teach us about step 2.
All right. Thank you so much, Cash. So now, great. You have set up your organization. You have set up all your organizational identities or sync your identity from on-prem. So now you realize you have thousands of employees on cloud. So how can you manage the access of them? How can you make sure the right person can perform their job, like your developers can go ahead and deploy code in our code base? Also, you don't want to give everyone a superpower role, right? And that is when you need to set up your identity and access management, or most people call it IAM. So IAM, in a nutshell, is really about giving you the control to set who can perform which actions on what resources. So in an actual example, for example, I can say, I want to grant Cash the instance admin role to my test project. That's going to allow Cash to manipulate my instances in the test project, right? Create, delete, etc. I can also grant, say, Siri the storage admin role in my project, the same project, and Siri can then access my data that I stored in the GCS bucket. Yet, Siri wouldn't be able to manipulate my VM instance because he's not the instance admin. The same thing, Cash wouldn't be able to access a GCS bucket unless they kind of coordinate, right? But the good thing, that's what IAM can allow you, a fine granular control of who can do what. So then now you probably can realize, wow, I have so thousands of employees. The policies sounds like will look very complicated. Don't be panic. No matter how end result might look complicated, the steps you are taking in order to set up the IAMs are always the same. The policy language is always the same. Which the steps you will follow is, first, create our IAM policy, and then set the policy on the target resource. So let's first look at what is IAM policy looks like. Here is a JSON example. As you can tell, policy contains a list of bindings. And so within each binding, you define members and roles. And in this example, all these members assigned with the same image user role. So let's take a deeper look at the members, which is the circled part. We allow 3 types of identities at Google Cloud. One is the users, which are the human users. 2, service accounts, who are the identities of VMs, services, so they're the representation for robots, pretty much. And the groups, obviously the group of multiple things, and you can put both human users and the service accounts into one group. And next, let's look at the roles. The roles are IAM roles, which is really a collection of permissions. So let's take a deeper look at what roles can be. At Google, we support 3 types of IAM roles. The first 2 types are primitive roles and the predefined roles. There are 3 types within the primitive roles, only 3: owner, editor, and viewers. They each have a very wide access and very wide set of permissions. They're meant to, remember we said a get started state, they're meant to get you started quickly. But yet, they're really not meant for production for exactly the same reason. There are 2 cores. Each have 2 wide access of the permissions. So what should you use in production system? Predefined roles, or sometimes called curated roles. What are they? They are just really fine-grained roles that Google defined for you that's specifically targeting a specific use case. For example, instance admin roles are most likely mapped to your developer functionalities, and the network admin, probably you'll give to your network admins, as the name sounds, to can help you set up the networks, firewalls, VPNs before your developer comes to deploy code. And our best practice there is always use the least privilege role. So do not grant any additional permissions unless needed. That's for your security purpose. And in order to better implement this least privilege principle, we also have a third type of IAM roles, which is custom IAM role. We made this offering publicly available earlier this year. As the name suggests, it's allowing you to customize what permissions you want to precisely put into your role. So there are two typical use cases that you need to use custom IAM role. One is you might realize our predefined roles are still too limited. Like some customers saying, I have to sometimes assign 2 or 3 predefined roles to each identity to do their job. And if I scale, it's a little harder to manage. Like many people on SRE used to have both log viewer roles and the monitor viewer roles in this example. So then you can create your own custom role to combine these 2 roles together. And going forward, you can just assign this particular custom role. Another use case is the opposite. Some customers find out our predefined roles are still too wide or doesn't necessarily meet exactly their business needs. A popular example would be instance admin role. They want to give to their developer. They want everything about it except the external IP usage for exfiltration, infiltration. So they don't want the developer to be able to create VMs with external IP. So they will just easily remove that particular permission from the existing role and create their own developer admin role. And next, since we learned about IAM policies, roles and identities, let's talk about a few best practices how to implement those in the most secured way. The first recommendation we give to you is always assign permissions and access to groups, not to individual users. So why is that? So I know it's very natural to think about, oh, I have roles we should assign to those users directly. But think about your employees could move around within the company. If you're directly giving them roles permissions on themselves, after a while you might realize it's harder to track, to understand what permissions this employee currently still need. Maybe he was in a different group and needed something else, but now he doesn't. But after a while, it's very hard to analyze and so that you couldn't achieve the least privileged principle, right? But if you can assign permissions directly onto group and then add or remove users from groups, say, so when one employee leaves a certain group, they get removed from that group, they automatically lose all those permissions they had before. It's much easier and cleaner to manage the access for employees. And at the same time, service accounts do not change roles and move around as humans, so we recommend you directly set policies on service accounts. So that's the first principle, and also best practice, grant access to groups. Here's another one that we have seen a lot of success from our customers, which is break glass style. One of the approach is, by the way, if you're not familiar with this term, think about fire extinguisher on the wall, right? They're protected by the glass so that if there is a fire, you can access it by breaking the glass. But that's a very invasive action, takes a lot of additional caution to do it. And by doing so, you kind of prevent a lot of accidental errors. So one of the styles to implement this break glass is to assign human users nothing but the project IAM admin role. What this particular role only allowed is set permissions, set policies, that's it. So if you give your on-call this particular role, they wouldn't be able to just go ahead and stop your VM in production system because they don't have the permission. But yet, as we said, it's called a break glass. So if emergency arises, if there's an urgent situation, they do have to go ahead and manipulate their VM instance. They can use their project IAM admin role to grant themselves, say, the instance admin role. And from there, they can go ahead and manipulate your VM instance. But then this extra layer of caution, extra requirements, can help you prevent a lot of accidental actions. And by the way, all these change of policies, setting policies are in audit log, so you can go back to trace that. And with that, I'm sure many of you already have questions, want to know more about service accounts. So let's invite Cash back to tell more about the service accounts.
Thanks. As most of you guys know, service accounts are quite fun toys to play with. They tirelessly execute all of our actions for us when we're not there at the keyboard. They run our jobs, they run our services, they never get paid, and yet they're always there for us. But sometimes they're hard to understand. And so I'd like to first help you get to know what the service accounts that we offer look like and feel like, and how to differentiate them and make sense of them as you encounter them. This is a common cause of confusion and errors that we see when we talk to our external customers. This is an IAM policy page that you see in the Google Cloud Developer Console. This is the landing page when you get to IAM. As you can see, this IAM indicates this is an IAM policy. This is the policy that grants access to this project and all the resources contained within. As Sophia was indicating earlier, policy is essentially just a mapping of the sets of permissions to a set of identities. So for instance, this grants me owner on this project. This is a service account. You can tend to identify them by the fact that they end in gserviceaccount.com email addresses. The name here indicates what it is. It's a service account that was created by default by the system to get me started using the cloud. It has editor access, which is fairly powerful, and clearly this is not a production project, right? Everything that we told you before about securing your projects was not done here. And so you could imagine what that might look like here. You've taken cache at google.com off, you've granted him project IAM admin, you actually granted him project IAM admin through his presence on a team called Team David. The service account at the top has been granted Cloud Data Store user because all it is doing is accessing Data Store, for instance. And so this makes sure that if the job is compromised, the impact and blast radius is limited to Data Store and not, for instance, my VMs or other things. These other service accounts here in the middle are a common cause of confusion for our customers. They represent the identities of services activated and essentially purchased from Google. I didn't create them, I don't own them, and I don't manage them. They're owned and managed by Google and protected for you. Yeah, they're kept securely under lock and key for only our production services to access. They've been granted particular API access to your resources in this project, and they specifically grant access to only the types of data that and operations that are in line with the business requirements of those services. And we basically review every one of those every one of those grants before we allow them to be granted to your projects to make sure that they actually make logical sense and meet your expectations. If I wanted to look at the service accounts that I own and I manage, you can flip to the service account tab. And here you can see that I have two service accounts, one the default one that we told you was created earlier by the system for me to get me started, but I also created another one called MyWebFE, which I am using to run my web front end. There are two ways that you can use these service accounts. The first way is to use what we call Google Managed Credentials, which essentially means that you don't have to worry about any of the key management or the rotation story. We keep the service accounts secure for you. It's a tireless task, but somebody's got to do it. They don't pay me enough to do that, but we make sure that they always get rotated for you, and they're kept secure. The basic idea here is that I can ask a service like Google Compute or Google App Engine or Google Cloud Functions to use a service account. Here I'm asking, for instance, Compute service to create an instance bound to my front-end service account. And what happens is an Actez check, a permission called Actez, will be checked to make sure that I have permission to use the service account and bind it to a job. And then once I've been granted access, that job will run continuously without me being there as that service account. And that VM, the code inside the VM, can go and access data commensurate with the permissions that have been granted to the service account. The other way of using service accounts is to download a service account key. And this is a less secure, we think, way of managing your service accounts and using your service accounts, because you have to take responsibility for making sure that key doesn't leak, and you have to take responsibility for rotating that key to keep it secure. It's predominantly there for you to use when connecting your on-prem systems to Google Cloud Platform. For instance, if you needed to do database backup or computer backup or something like this to cloud storage, you could use a service account key to do that. Many of you are Compute customers, I'm sure, and you've seen in the user interfaces and the APIs and the command lines that when you create VMs, we often ask you for a set of access control scopes or just scopes when you're creating a VM. We call these VM lock scopes, essentially. They're a legacy feature of compute from the days before Google IAM came on the scene. They caused some confusion to our customers, and so I'd like to clarify some of the usage here. They used to be used for some coarse-grained access control, but they're not really good for that these days. So we highly recommend that in general, when you see these things, you close your eyes and don't use them for access control. Rely on IAM for access control, and instead give the VM a fairly high-level scope, such as Google Cloud Platform, or full access, depending on the user interface you're using. And if you need to call other APIs like Calendar or Maps or something, you can grant those scopes as well. And I think Sophia has something more to tell you about managing your resources.
Yep. All right, thank you, Cash. Yep, so now we have got our employee imported here into Google Cloud and set up IAM policies onto them. Also set up additional IAM permissions onto the service accounts. So now what's left to do? You're gonna come here to create VM instances, right? Creating disks, images. How do you make sure you manage the access to those to secure those resources? And that's what the sections we're gonna be talking about. So let's have a quick review of what Cash showed earlier about our policy hierarchies. At Google, we offer 4 levels of hierarchies: organization, folders, projects, and the resources. So you can set permissions, policies on each of a level, and any level down below will automatically inherit it. So for example, if I want to give architect the image user role for all the team A, so then I can go ahead and set that policy on the folder level, team A. Then this architect will automatically become the image user role for all the project A, project 2, and etc. Any projects under the folder. So this gives you a lot of flexibility to use. But sometimes you may want the opposite. You actually want to run into the situation you only want to give access to particular resource instead of grant at a higher level. So what would you do there? You can set the policies onto the individual resource like VMs, disks. But probably many people are familiar with Compute Engine IAM. You might ask me, I didn't know that you were able to do so. I thought at the lowest level, you can set a policy with the project level. And you're right. Until this week, we're actually very excited to let you know that we are going to support resource-level IAM in beta very soon for you guys. Highly anticipated feature, seems like. Great. And that what allows you to do is exactly to set IAM policies on individual resource, like VMs, disks. This totally enables a whole new set of use cases. For example, a common use case is within organization, people often like to share images with other developers or different users. Yet, without a resource level IAM, they have to give image user role for the whole project or above, right? But sometimes you don't want to give them access to all the image, just the production image, right? Before resource level IAM, what you had to do was create a separate project and only put a particular image in that project so that, and then grant policies onto the project level. That's suboptimal and a lot of management overhead, right? So with this resource level IAM, you can simply just grant the IAM policy onto the particular image. In this example here, I want to grant the beta tester group the access to the particular beta image. And just by simple one line of code, you can achieve that now. So here's a real-world example of sharing images as we were talking about the scenario, right? So now you can create one single image project and then put in your production image together with all your beta testing image in the same project, and only grant developers access to the production image, so to make sure everyone uses the most supported and verified version, and giving the beta testers access to the beta testing images. So now you probably start to thinking, yeah, I can set IAM policies on each beta testing image to give the beta testers. But yet, if I have many of the beta testing image, I have to set the policy on individual image, every time. Would that be a little bit kind of a lot of work to do, right? And we have thought about that for you. So if you want to have another way to manage resources access at scale, they'll be happy to find out another beta feature that's coming soon to you, which is name prefix IAM condition. What this allows you to do is exactly manage your resources under the condition based on name prefix. So let's backtrack a little bit to talk about what is conditional IAM first. As I mentioned earlier, IAMs allow you to define who can do what on what resources, right? And now conditional IAM giving you additional power, which is adding a condition now to the IAM access. So we wouldn't grant access unless the condition is also met. In this name prefix condition, we will say, for example, you can grant beta testers the image user role on the project, but only if the image, the name is starting with beta. That way you can achieve what I just mentioned. By setting one policy, the beta tester groups will have all the access to all the images starting with name beta. And that's even include the images you yet to create. As long as you created them under the beta, underscore name, all your beta testers will have access to the image. Another common use case customers ask for that you can utilize this name prefix condition is to build this so-called developer playground. Many companies, when they have a new developers join in, they like to put them all in the same project to test out, to build their prototypes. Because creating each one an individual project is a lot of overhead. Yet they don't want every developer to accidentally stump upon other people's resource. So having this setting up the name prefix condition to based on each developer's email address solves the situation so that each developer will still only have access to the resources starting with their names, and yet they can still enjoy within the same project the convenience and also the high network performance. More excitingly, you'll find out conditional IAM not only allowing to do name prefix-based condition. We have two more type of conditions we support, which is access level and the datetime condition. Access level utilize the security context thing that Cash mentioned earlier. Sorry. That we will look at the raw attributes comes in from the request, and then to decide, even for example, the instance admins say can manipulate instance, right? But you can say, any actions to manipulate the instance for production project, this request needs to come in from my corp network. That way, so even the instance admin sitting in their home trying to do some work, the request will be rejected. So giving you another layer of security and protection. Datetime condition, just as the name suggests, it allows you to get a timer around your condition so that you can say, grant a powerful access to your on-call, SREs, but only during their on-call hours. Before this, you had to grant access and then remove access manually at the end of their on-call time. But now you can just simply set up a condition, time-based condition, and it can be recurring as well. So we can help you manage that. All right. So we talk a lot about IAMs, conditional IAMs, resource IAM to help you better manage your resources. Let's talk about another dimension, angle to how to manage the access for your organization, which is the famous organizational policy. Organization policies are meant to work together side by side with IAM policies. But there's a key difference, which is org policies, the enforcement will be there regardless of IAM access. So for example, if you utilize the first example shows the no external IP org policy, you can set that on your project folder or organization level saying, oh, in my organization, for example, I don't allow VMs to be created with external IP. Then even the person supposed to have the IAM permission, like compute admins, wouldn't be able to do so. So this helps preventing a lot of human errors. Again, it's an organizational policy enforced at whatever level you're granted. And similar as IAM policy, any level below will automatically inherit that. Compute engine will have a bunch of very useful org policies that you can read about, like trusted image, disable serial port access, etc. There are particular two more organization policies that we'd like to call out that we really think you should know about them, and I would highly recommend you to enable them. The first one is domain-restricted organization, sharing organization policy. What this allowing you to restrict the resources wouldn't be shared outside your organization. We have seen mistakes done from before from customers that, for example, their developer will go home and they're trying to do some work, but they accidentally shared this image with their IP, with their own Gmail account, and there is information leak there. With this organizational policy, you can secure that resources wouldn't be shared to anywhere outside your organization. The next one is disable service account keys. This piggies back what Cash mentioned earlier. We want to have we recommend you to use a Google managed key instead of user-generated credentials. And if you enable this org policy, it will prevent exactly user-managed generated keys so that you wouldn't have a long-living keys that developers hold, and that might expose additional risk to your organization, to your environment. And we have a bunch more organization policies we can introduce for you. Yet you can read them online probably better than what I can say each about them. But I think more interestingly, you'll be interested in finding out how is a real customer like 2 Sigma set up and utilize these IAM policies and org policies to build their environment. So we're very happy to invite Nick, the head of cloud security at 2 Sigma, to tell us about your story. Welcome.
Thank you, Sophia. Yeah, we're also very excited about IAM conditions and conditional roles. My name's Nick. 2 Sigma, I'll talk a little bit about our business to put our threat model into context. We're a technology-driven, data-driven, quantitative investment manager. Really what that means is we use computers to analyze a ton of data sets and try to make market decisions based off that. We're obviously very worried about external attackers, though we have a very small external profile. So although we're worried about volcano fortresses, we're also worried about our internal users. And that's not to say that we don't trust our people. There's some extent to which we don't trust them, but we do trust them. But if you follow security and compromises, you know that sophisticated attackers are targeting people with legitimate access to data. And we have some sort of friction whereby we need our people to have access to the data and the resources they need in order to do their jobs, but then also mitigate the risk of mistakes or intentional compromises. So we want to protect our IP. And one of the big use cases we have for Computer Engine is really as an extension of our data center. We run a lot of trading simulations or sort of model tests and simulations that use tons of compute. And that's not exposed to the internet at all. It's in a hybrid type environment. So things like what Sophia mentioned is we don't want external IPs in that environment. Even though there's no internet access, mistakes can happen. And we believe very strongly in defense in depth. You don't want to be one error or one failure of a control or one compromise away from being on the front page of the papers, or in our case, potentially out of business. So we apply organization policies as a really cheap and easy to implement control, but with really powerful implications, like no external IPs. Something else that's really interesting to us is a really useful feature is the ability to connect to a compute instance, a serial console, if you have a network outage, and troubleshoot it. Our issue is that that doesn't take into account any of our firewall policies or network configurations, so we hate that and we turn it off. You can tackle this again via IAM, but one of our use cases, again, in enabling velocity for our teams is my partner team that runs this environment would really hate it if I didn't allow them the ability to configure metadata on VM instances where you can turn this on or off. Like they need that for bootstrapping, so a safe compromise is to use this organization policy to enforce that control and then be able to be more lenient on IAM. Again, we really want to be restrictive about what images we use. We have a lot of custom configuration that goes into those. So we have, as suggested in the best practices, we have a single project where our trusted image is built, and then we use an org policy to configure our environments that only images from that environment can be booted up and used. The flip side of that is also obviously really important. Like we too have a developer sandbox like everybody else. And we don't want, in that environment that's wide open and connected to the internet, our images that are baked with our IP, in some cases, and in other cases, sensitive configuration details to be used at all. So we use another org policy for that. And finally, as Sophia mentioned, domain restricted sharing really is a no-brainer for us. It's super easy to implement. And these things really provide us a lot of access. Again, other best practices, this is really defense in depth. Like we rely very strongly on using custom IAM roles only. We tailor our roles based on least privilege, and we use a whole host of other services for our security posture. But these offerings and the ones that have been discussed today are really essential for us in terms of enabling our business without adding unnecessary friction either to our security team or to our client teams. So with that, I'll hand to Siri to wrap up with the final section of how to secure your environment.
Thank you, Nick. So hi, everyone. My name is Suri. I'm another product manager on the GCE team. And actually, first of all, I just want to say thank you so much, Nick, for talking with us today. It's been an absolute blast and a privilege to be able to work with you guys to really secure your incredibly valuable IP. So thank you again. Let's hear another round for Nick, 2 Sigma. Great. So I'm here to take us home and talk about the final step here in our 6 steps best practices, and I'm here to talk to you guys about platform transparency and data integrity. So you may be wondering, right, what does that mean? Right, so to boil it down, here at Google Cloud, your trust is our top priority, right? We understand that many of you, many of our customers really rely on Google Cloud to run their businesses, right? And we know that wouldn't be possible without having deep trust in how we administer our platform. So the way to think about this is when we talk about platform transparency here, what we really mean is what are the tools and what is the information that we're giving you guys as our customers to really have faith and trust and to really build that trust in how we're administering our platform. Right? And as we'll see, that takes a few different forms. The first thing I want to talk about is how your data is encrypted. Right? And so before I go any further, I just want to say that at Google Cloud, regardless of how you store your data with us, we are going to be encrypting your data at rest, full stop. Right? And in the spirit of transparency, yeah, thank you, Cash. In the spirit of transparency, you can go online. If you Google, for example, Google Cloud Security White Paper, we have a lot of white papers and other resources for y'all so that you can read about our security best practices in general, how we do that encryption at rest, things like that. So I would highly encourage all of you, if you're interested, to go take a look at that following this presentation. What I'm talking about here is the options that we give you all in GCE, in Google Compute Engine, for how we actually do that encryption at rest. Right? And so here you see we have 3 different options. So I'll go left to right, and they kind of fall on the spectrum of automation. So how much control we give versus how automated the encryption actually is. So we'll start with the one on the left, which is encryption by default. Right? So if you go into Google Cloud Compute Engine, you spin up a disk, you spin up an image or a snapshot, and you just have all the default parameters, we will encrypt that for you automatically at rest, no questions asked, using our world-class encryption methodologies. Right, so you don't have to worry about it. You just go ahead and spin it up, encrypt it at rest. Now, we know that some of you, as our customers, you maybe work in industries like banking or financial services or consulting where you're expected or you're legally obligated to have some more rigor or more control in how your data is protected at rest. Right? And so as a result of that, we give you some more options here to give you more control over how your data is actually encrypted. So I'll talk about that middle one next. And this is a thing that we call customer managed encryption keys. And so here what you do is, right, you create a key in another GCP service called Cloud Key Management Service. So you create that key, and then when you create a disk or an image or a snapshot in GCE, what we go ahead and do is we ask you, hey, which one of these keys do you want to use to actually protect this content, right? And so here, you're deferring the creation and the storage of the keys to GCP, but you're still in full control of the life cycle of that key. You can revoke access, you can disable the key, you can delete it, etc. Right? And then finally, on the very right there, we have another option called customer-supplied encryption keys. And so in this case, what happens is we just ask you for the key, and Google Cloud is actually deferring the creation and storage of the key to you, the customer. Right? So this gives you full control. When you create the disk, for example, we ask you for the key. We obviously don't store it, but we use it to encrypt your content. And the next time that disk is used, say at VM startup, we go ahead and ask you for that key again. Right? So this is full control, and this is really popular, again, in some of those verticals like banking. Okay? Switching gears a little, oh, actually, just kidding. Continuing on, like most features in GCE, these controls are available to you in the UI, in the command line, or in the API. So here I'm going to show you, just for simplicity's sake, what it looks like in the UI, what these 3 options look like in the UI. So here, this is the VM creation page. This is when you create a VM, we ask you to create a boot disk, of course, and you can actually select either the automatic option on the far left, where no questions asked, we just go ahead and do it for you. In the middle, you'll see the option to specify a key in Key Management Service. So that drop down is a set of keys you have there. And then on the far right, that's the customer supplied option where we ask you what the key is, you input it in that box, and you go ahead. So the takeaway here really is that, however you want to manage how your data is encrypted at rest, we make it really easy for you to get started and to get going with that. So switching gears a little bit, another question that we get asked at Google Cloud a lot is, well, hey, you guys are administering our data. How much access do you have to it? Right? Are you reading it constantly? So we know a lot of you may have sensitive data in our cloud that you trust us with. We know many of you may also have auditors who ask the same question, right, as part of doing their job. And so here, the first thing I want to start with is at Google Cloud, right? We do not access your data for any other reason other than to fulfill our contractual obligations to you. Okay? So that means whenever there's a data access event, right, whenever someone goes to access your data, it has to have a very strong business justification, and it has to be in line with that particular statement there, fulfilling our contractual obligations to you. You can go online again, you can Google access transparency, and you can find out the well-defined set of sub-reasons for why we access your data. And it turns out by far the most common one, I think over 95% of these access events happen because our customers, you guys, asked us to access your data as part of, say, a support case, right? But on top of that, you don't have to take our word for it, right? Whenever Google accesses your data, we'll create an audit log for you in near real time, right? So that you can hold us accountable to that statement there, right? So let's take a quick look at what one of those audit logs looks like. So this is, the font's probably a little small, so I'll just walk through this audit log for those of you maybe in the back who can't see. So the first thing you'll see is this is just a standard audit log, but it's created when an access event happens, when a Google Access event happens. And the first thing you'll see highlighted in yellow there is we give you a reason why we access your data. It aligns to one of the sub-reasons for fulfilling our contractual obligations to you. And so here you see this is actually a customer-initiated support request. And we even give you the case number so that you can follow up, understand why exactly we're accessing your data. Here likely it's because you asked us to. And then in green, you see we give you a lot of information around what exactly did Google do with your data once during this access event, right? So which method did we call? Which resource did we call it on? How long did it take? What project did it happen in, et cetera, right? And so this is really aligning with our goal, with our principle of making it really transparent in how we administer our platform and giving you, our customers, the tools to hold us accountable for that, right? Okay, so that brings us to the end. Just to quickly summarize, right, we talked through 6 steps for best practices in Compute Engine. I see a lot of you are taking pictures. I just want to remind you all that this, like all talks at Google Cloud Next, is going to be posted to YouTube. So you can go watch that, drill into one of the steps that was particularly interesting to you, et cetera, right? And the final thing I want to leave you all with is this, right? Google Cloud, like the rest of Google, we take security and privacy incredibly, incredibly seriously. Right? So we're constantly improving, and we're really, really receptive to feedback, right? So please, we've worked with 2 Sigma. We want that to be the rule, not the exception. We're really open to working with you all. We want to make sure that what we're doing aligns with your needs, and we want to make sure we address any gaps, right? So leave us feedback. Go to user voice. Go to the developer console. Leave us feedback about this or really any other features. It really does help influence our backlog, influence our decisions, right? So with that, thank you all very much. Hope you have a good rest of your time here.